Good morning, everyone. Am I audible to you all?
Yes, sir.
Yes, sir. Good morning.
You. So, we have done demand estimation part. Today, let's discuss about the demand forecasting. Why this topic is important, so I should say at the very beginning, because for demand estimation, we use past data, historical data. Using the historical data, we estimated the demand function. So, about the past data, we know the history. But using historical data, why we estimate demand equation or demand function? If we stop there, our work is not very much meaningful. Why? As a businesses, as a managers, as a entrepreneurs, we should know what will happen in the future. So therefore, most important part is to forecast the future. We need to get ready now for the future. If you are producing and selling something, then it is better for you to know about the demand of your product in the future. Maybe future, due to some reason, demand may go up, or sometime demand may go down. Without paying attention to those ups and downs in the demand, if we produce continuously the same amount or increasing amount, sometime you have to experience a big losses. That may be end of your business. Assuming that the past is repeating in the future as well, using historical data, assuming the same thing happen in the future as well, we have to use estimated demand function for future forecasting purposes as well. This can minimize risk and uncertainty in the future. I'm not saying that 100% accurately we can estimate, we can get the clear picture about the future. But as much as we can minimize the possible risk and uncertainty. That's why we forecasting the future demand. Future demand from the customer side mean, if you are the businessman, your sales. Okay. So that is the importance of this topic. So briefly I explain here what is meant by the forecasting. Forecasting is the process of estimating a variable such as the sales of the firm at some future date. Variable means in our case demand. In the same pattern, you can estimate your cost. You can estimate the labor demand or anything. The process is same, right? Your sales is from the customer side, as I told you before, demand. So demand for your product is increasing means your sales is increasing. So that's why forecasting is the process of estimating a variable. In our case, demand of the firm at some future date. The aim of the forecasting is to reduce the risk and uncertainty. Risk and or uncertainty. Right? So because businesses always involve risk and uncertainty. So if we can minimize those, it is very much better. Risk or uncertainty that firm faces in the short-term operational decision making and in planning for its long-term growth. Short-term decision making and long-term growth planning. For both, it is very much important. So that's why we're paying a big attention to this. So there are so many forecasting techniques. We'll pay some attention to a few of those. So here we have three type of forecasting techniques. Qualitative approaches, that is also called judgmental forecasting. Quantitative approaches, time series forecast, and also we are using associative model for forecast, that is econometrics forecasting. The same thing again, forecasting technique. Judgmental mean uses subjective input such as opinion from consumer surveys, sales staff, etc. For example, why this is called subjective? Say, for example, you are the country manager for sales, right? You're working in a big company, you are responsible for whole country. You are the sales manager for entire country. But under you, you have maybe provincial or district sales managers, right? One from Badulla, one from Anuradhapura, one from Puttalam, one from Galle, like this, covering entire country. You have district sales managers. So time to time you can get the meetings and get some updates as well. Okay, so suppose that you want to know about the future sales. So what you can easily do, you can call all the district managers to one place, somewhere in Colombo or the headquarters, wherever it is, and you ask from each and every. How about the sales in Ratnapura district, for example? So Ratnapura district manager says, the last couple of months, we have been increasing the sales in Ratnapura districts, 5 to 10%. So I guess that, so in the next couple of months as well, I can keep this momentum. So sales can increase maybe 5 to 10% rate. So and then the Munragala or the Badulla district or Ampara or Vetikala, whatever, and the manager is explaining, I also can do the same for my district. The sales is good. I can increase the sales maybe 4 to 6%. But actually, he is here, the district manager is not very much sure about that, because he is just telling a number, because in front of others he cannot say, for example, he is not performing well. Even though he is in his area sales is not increasing, can he say in front of others he is not performing well? So therefore, he is also just telling some average number, right? So that's why it's called subjective. Personal feelings are there in the answers. Likewise, everybody will say in front of the boss, that means country sales manager, so they all increase in the sales, can increase in the sales maybe on average, say 5 to 10%. Taking this number as accurate number, country sales manager taking rest of the decision, next year production and everything, advertising campaign and everything on the basis of this estimated figure, because all the district managers guaranteed that can increase the sales 5 to 10%, right? So accordingly, sales manager is giving opinion for his production team and the advertising campaign and everybody. Excuse me. Dulipa, good morning. Oh, Sorry for the disturb. So therefore, the sales manager is taking the next decision, maybe related to advertising, the production for the next year, and so on and so forth on the basis of that. Now tell me that how this kind of judgmental forecasting accurate? So to what extent it is accurate? Is it reliable? What is your opinion on that? If you have any experience, like this, because you are working out in the private sector most probably, so you know how the information is gathering by your, boss. Or maybe you are the boss. So how you can take those information, which will very much helpful to managers to take decision. Do you like to add something to this story? Okay, so no one is talking. So what is the weaknesses of this one? This is very much subjective. No scientific basis on this judgmental forecasting. Right? People just thinking and telling. It's always its personal opinion is there in the answers. So it is not very much scientific. And then the time series data, time series forecasting model uses historical data, as I told you at the very beginning, assuming the future will be like the past. That means future will be like the past. History repeating, in other words. Under this one, we will study simple MA, moving average techniques, weighted moving average techniques, exponential smoothing techniques. And the third one, associative model, uses explanatory variable to predict the future. That means we can use simple linear regression, multiple linear regression, and also nonlinear regression techniques as well. Quantitative forecasting approach is based on the actual market data and also assuming that history will tend to repeat itself. So analysis of the past demand pattern provide a good basis for the forecasting the future demand. Okay. So therefore, we dealing with most frequently with the actual market data. Majority of the quantitative approach fall in the category of time series. Over time, we collecting the data. So, if you take the time series data, so we can divide the time series data into 4 main categories. One is secular trend, that is long-term trend. Number 2, cyclical fluctuation or cycle fluctuation. Most probably it's called cyclical fluctuations. Number 3, seasonal fluctuation, seasonality. Number 4, irregular variations. Now come to number 1.
Sir?
Yes, Inoka?
Sir, earlier we divided time series forecast into 3 categories like simple MA, weighted MA, exponential smoothing.
Yeah.
Those are what?
Yeah, that is correct, right? If you take time series, that is for forecasting techniques.
Right, techniques, okay.
Techniques. This is, if you take the time series data set, you can identify this kind of fluctuations. Right?
Okay.
Right? Thank you, Inuka. So, for example, suppose that let me take a okay. Suppose that we have sales data like this. Here is the, you can put sales figures here, sales, time here. So, collecting data over time, you can plot the data like this. So, over the time period, so you plot in the data like this. Okay, these are the data sets. Now, what can you say about the sales over time period? Suppose that here maybe starting from 2000. Now here is 2025. Over this 25-year period, what you can say about the sales pattern of this company? If I ask you to draw a kind of a smooth line to representing all these data, so probably here you can see this kind of pattern. What do you say? Is it reasonable? Hello?
Yes, sir.
Good morning. Yes, who is speaking? Okay. 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 So yeah. So Mister, now I'm in a one lecture. So can I call you a little later? Okay. Okay. So this is you can see a long-term trend. Okay. So this, I think this line is very much reasonable line to this actual data. Okay, maybe if I ask some one of you, I mean, to a, you know, probably you will draw a line like this. This line is also okay, but you know, whatever the line that you can see roughly, there is a increasing trend over time. Okay, but actually, though there is increasing, this is actually secular trend. Secular trend. It is long-term trend. Long-term, it is upward trend. But you see, if you have a closer look, so this data pattern is like this. Somewhat like this. Okay? Or else sometimes that you can draw a line bit lower than this. Okay? Not this one. This is the actual pattern. You can see little ups and downs throughout this 25-year period. So you understand what I'm telling? Yes. Yeah. So if these are, maybe a 3 to 4 year period, up to this point, business is progressing, right? And again, another same 3-4 year period, business is going down. This is upward trend, again going down. Okay, these are called business cycles, right? Business cycle, cyclical fluctuation, right? So in every 3-4 years time, over this long period of time, we can see, for example, USA, latter part of the 90 decades, and also starting from 2006, 7, 8, right? It's affected to the entire world, right? So if some kind of fluctuations happen in the US economy, it is affecting, because US economy is a big economy, can make impact to the rest of the world economies as well, right? Because of the volume and all these things. So it is affecting. And also, this is called, this ups and down in a regular time interval is called business cycle or cyclical fluctuation. And another factor that you can notice here, okay, all this top position in the progressive period, suppose that it is happening every year, maybe say March and April, right? So every year, March and April sales is good like this. And every year, this period, sales is not very good. Maybe in August, September, this is August, September, and after this, again, August, September. So if we can identify these kind of things, this is called seasonal variation. Seasonal variation. Okay? It is every year, for example, in Sri Lanka, ready-made garment and sweets business. Right? Ready-made garment and sweet business. Which period is very good? If you have the quarterly data, 4 quarters in a year, right? Think about the sales for the sweets varieties and the ready-made garments. End of the 4th quarter, maybe starting from December, mid, there can be a very good sales. It remains till mid-January. Okay, end of 4th quarter and at the beginning of the 1st quarter of the next year. Then sales is good. After that 2nd quarter, sales is coming down. And then after the March, 2nd quarter of the year is starting. So April period, again, for the 2 products is good for the sales, right? Increasing. And after April season over, then again, sales is coming down. So the same pattern is happen in every year like this. Okay? So this is seasonal fluctuation. I hope that you are understanding these things. If those are clear?
Yes, sir.
Okay. And so these kind of things actually we can predictable. The 4th component is irregular. Irregular means we cannot predict. Suppose that, irregular means, due to some unpredictable reason, right? Unpredictable reason. Say, for example, typhoon situation, bad weather condition, right? And the labor unrest situation, and civil war, riot situation, right? Now, suppose that in Sri Lanka economy, very much shaky, still it is shaky, and compared to year 2022, this situation is much better, even though we are at high risk level even now. Compared to 2022, this situation is much better, but it's highly vulnerable. And in this situation, suppose that harbour people, I got, for example, harbour, it is a key economic, center, appearance. In Marmastana, harbour. Harbour people, so due to any reason, maybe salary or whatever, going for a labour strike for couple of weeks continuously. What will happen? Any idea if such a thing happens?
We lose lot of money to the country.
It is affecting every part of the economic activities, right? So maybe these 2 weeks will, damage the entire economy. Sometime you may not be able to reverse it back, because that type of danger situation is there in our economy, right? So, this is actually unpredictable. Sometimes our labor union, they not understanding the real situation. Union people thinking only about union members. They are not thinking about the outsiders, non-members. They are not most probably thinking about the country. They are not most probably thinking about the place they are working, right? At least even to protest, there should be a firm, right? If harbour or any other factory or business losing and going to close, right? So in future, they don't find any place even to have a kind of protest. So our labor unions' attitudes most probably is not like this. They thinking only about, their members' welfare or the facility or whatever. Right? Now there is a kind of a unrest situation is emerging from every sectors. If you take the newspapers, because of this salary issue, no one is clearly understood so far what is happening. Right? If among you, maybe if the government workers are there, can understand this one very clearly. Even among the university lecturers, among the doctors, among the nurses, among the principals, among the school teachers, among other harbour people, as I told, right? Nobody knows what is happening, what has happened to the salary, what is the new suggestion, right? Whether the salary increasing or not. But the government says that salary increase. But, some outside parties calculating and showing that, no, this is not increase. The government is cheating. If everybody start protesting, at the same time, so you see, there will be a serious damage to the economy, right? Even though the government people purpose and their, their intention is very much progressive and very much clear, they are not corrupted, whatever the things, that they say, right? They are, they have to face to this situation, right? They can't say that, no, you can't strike, right? If all the people, do like this, I don't think. So it's serious, right? It is true, maybe, the previous leaders spent huge amount of money for foreign travels and all, as, revealed in the parliament yesterday, right? So some questioning about how you can do 11 people foreign travels with 1.8 billion as well, right? So those are the interesting debates, okay? But economy is highly vulnerable situation. So what I wanted to highlight here, irregular pattern, due to unexpected reason, right? So even here, for example, during this bad situation. So here sales is coming down, but suddenly you can see the very good sales point here, right? And here in this period, sales is going up. Even though it's during this period, this drop is here. These are irregular, right? This is how we can break time series data into these four different components. Okay, so now you can see secular trends are noted by upward or downward sloping line, long-term movements in the data. So you can show the population shift, changing income like this. And the cyclical fluctuation is a data pattern that may cover several years before it repeats itself. It's a wave line, for very short period, maybe 2 to 3 years or 3 to 4 years, wave-like variation more than 1 year's duration. Economic, political, agricultural conditions, you can show like this. And seasonality is the data pattern that repeats itself over the period of 1 year or less. Short-term, regular variation data, weekly, daily, restaurant and the supermarket experiences. There's a seasonal variation. And the irregular variation caused by unusual circumstances, severe weather condition, dry situation or the typhoon situation, the strike or major changes in the product or service, strike, right? And also the managers purposely introducing some different quick changes to the production. So it is very difficult to forecast it. Okay, so you have to understand these kind of things as well when you going to forecast the future. So the same thing here you can see again. So this is the secular trend, the same graph, and these things, cyclical fluctuation. Okay. And the other two you can see here in the bottom line. The dotted line is actually seasonal variation. As I told you, the top sales is coming every year in between second and third quarter. You see here in between second and third quarter. This peak is also second and third quarter. And the lowest sales performance is happening here at the end of the fourth and the beginning of the first quarter. You see, it is same every year. So this is seasonal variation. Okay, and the blue color thick line is irregular. Even during the progressing period here, you see sudden drop you can see, sharp drop. Maybe this is bad weather, or strike, or civil war or some situation. And then sharply going up. And here you see, this is sales is down, but suddenly you can see quick up. Right? Maybe due to some unexpected reason. Here also, sales is very low, but during this recession period, you can see little upward. Okay? These are random influences, it's another name, or irregular fluctuation. It is very difficult to forecast those kind of things. So if I ask you to explain these kind of things, better you study a little bit more. So then you can explain about all these four components very clearly with the, when you're explaining those things, better add some real world examples as well. And the techniques for averaging, as I told, Inoka also asked moving average techniques and the weighted moving average and also exponential smoothing. this is simple moving average, and average period is given or selected. You can select as a researcher, or else it can be a given number. Forecast for the next period is the arithmetic average of the average period. Average period, most recent actual demand. This is called simple moving average. Why it is called simple? It's called simple average because each period used to compute the average is equally weighted. Equally weighted. Right? For example, suppose that year 2022, so Sri Lanka experienced negative growth, maybe 3 point something, not the exact data, and 2023. So it's very much low but positive, right? I don't know figure, maybe say 1%, and year 2024, say it is again 3.6%. And what is year 2025? If we take moving average techniques here, 3 period moving average, what you need to do, you need to add these 3 together and divide the number by 3. Okay, and then think about how it is valid actually. So 2025 growth rate is, giving the equal weightage for all the 3 numbers, right? It is not very much realistic because rather than affecting, for example, so 2025 growth rate is heavily associated with immediate previous year number than the very much oldest number, right? So this is 2022 minus is very much old number. It has already gone, right? What we have done in 2024 is closely affecting to the performance in the 2025, right? And the next, what we have done in 2023 is also affecting, but this one 2022 is least affecting. So then giving equal weightages to all the 3 numbers and dividing it by 3 and taking this is the forecasted value, it is very much unrealistic. So therefore we have to give some weight for this one. So we will discuss those things in the next one. So that's why anyway it is called simple, but giving equal weight. But equal weight is always not accurate, right? At least we have to give weight 60% or more for this one, and 30% for this one, and maybe 10% for this one. This is somewhat okay. This is called weighted average. Now we are talking about the simple moving average. So why it is called simple? We are giving equal weightage for all the numbers. And why it is called moving? Because new number comes, all the number we deleting or we are not using. Because as the new demand data becomes available, the oldest data is not used. Right? So that you can go ahead like this. We'll do some very simple exercise as well. So take this data. You see, it is a call center data. So number of calls receiving to the call center. Day 1, the call center receives 159 calls. Day 2, 217, and so on. Day 12, 159. Use 3 period moving average techniques to forecast day 13 number of poles. How you can do it? If it is 3 period, you can take latest 3 period data. That means starting from day 10, 11 and 12. Others are very old. 168 plus 198 plus 159. Okay. So adding all these 3 numbers together, dividing it by 3, we're taking this figure. So we are expecting 175 poles in day 13. F means forecast, 13 is day 13 forecasted value. Okay, but we are not giving any special attention to these days. Maybe this is Wednesday, this is Thursday, this is Friday, or maybe this is Friday, this is Saturday, this is Sunday, right? Are you expecting the same number of poles on average for all these days, irrespective of the day? Wednesday, how many number of poles? And weekends or holidays, are you getting the same number of poles? So that is the problem of the moving average, simple moving average technique. But anyway, we can't criticize. This is the way that you can take the forecasted value using simple moving average. But in that method, there are some inherited disadvantages, right? Mainly, we are giving equal weightages for all the numbers. That is unacceptable. And so, due to these weaknesses, then statisticians or the mathematicians move on to this one, weighted moving average. Use the weighted moving average method with an average period 3. Now here 10%, that means 0.1 for oldest data, 0.3 or 30% for the next one, and 60% for the latest, right? So now this is the day 10, 11, 12. 12 is the latest, closest day. Therefore, we are taking 60% out of that. And the middle one, 30%. Oldest one, 10%. And according to this weighted moving average, for forecasting day 13, we get this number. Earlier, we got 175. Now, this is almost 172, right? So, that is the forecasting value from the 2 different methods. So, this one is quite okay, even though there is no significant difference between the 2. Right? This is, better way because we are giving the weighted weightages for the recent numbers. And exponential smoothing is another technique. So, what is this? This is the formula actually for exponential smoothing. You don't try to memorize these formulas. If the formula needed, I'll give those things in the question paper itself. Okay. This is smoothing constant. W is a smoothing constant. So you can, it is up to the researcher giving value for these. So here for this example, if you can using 25%. And this one, A is actual figure. You write the word actual. F is forecasted. A is forecast. Sorry, A actual, F forecast. T minus 1 is, T is current period, T minus 1 is 1 year before, previous year. right? So ft is forecasted for the current year, ft minus 1 previous year forecasted value, at minus 1 is previous year actual value. Okay. These are the definition, and if you pay little attention to this one, so what is this actually? Within the parentheses, at minus 1, what is it?
Actual forecasted.
Okay, suppose that now we are in 2025, right? What is t minus 1? T minus 1 is
2024.
2024. So at minus 1 is actual in 2024. This one forecast in again 2024. So now we are taking the difference. So how you understand this difference? Because assume that we have done these things in year 2023. 2023 we have forecasted 2024 value. Now we are in 2025. So we realize what actually has happened in 2024. This is what we got, ft minus 1. Actually we got this number, when we were at 2023. Right? So now we can compare how our forecast is accurate. Right? Is there any difference between the two? The value within the parentheses we are identifying as forecasting error. Forecasting error. Okay? If our forecasting is very much accurate, what should happen to this error? The value of the parenthesis should be very much minimum. Right? If you have not forecasting accurately, there will be a very big number within the parenthesis. You got the idea?
Yes, sir.
Yes, sir.
Okay. So, out of this forecasting error, we take some percentage, that is smoothing constant. Selecting the percentile value is up to the researcher. Here in this case, 0.25, that means 25%. Out of the forecasting error, we take some percentage and adding it to the previous year forecasted value. That will be the current year forecasted value. Okay, so this is how you can calculate it. Use the numbers, the given call center data to calculate this one. Then you can clearly understand this one. Suppose we need to get the F13. What is F13? What is F13?
Forecast for the 13th day, sir.
Okay, forecasting for the day 13. But we have the data up to day 12, right? So, if we need F13 here, what should be this number?
F12.
12. What should be this one? Actual in 12, day 12. This is forecasted in day 12. So therefore, day 12 forecasted value we need. That's why we forecasting this one. Okay. To forecast the day 12, here you need actually, what is this one?
Day 11 forecast.
Day 11 forecast. So that's why assume that day 11 forecast value is this one. It is given, right? you are using day 11 forecasted value here. And then 25% out of the forecasting error. What is this number? Day 12
Actual of the
actual.
day.
Actual.
This is day 12.
11.
Sorry,
Day 11.
day 11 forecast. The difference between the two is forecasting error. Out of that forecasting error, we are taking 25% and adding it to the day 11 forecasted value to get this number. Okay. Now, using this number here, we can calculate day 13 forecasted value. So, according to the smoothing, exponential smoothing, we got say 170 almost 9. According to the weighted moving average, we got 172. According to the simple moving average, we got 175, right? According to the three moving average methods, these are the numbers we are getting as forecasted values for the same data set. Right? Slight differences are there. Right? Lowest one is 172 and the highest is 179. Okay? It is up to the researcher choosing one of these three methods and giving some fair justification. So, if you take 179, so nobody can say that this is wrong. If you take 175, no one can say this is wrong. But you should be able to, as a researcher, give some acceptable justification for each. Then it is okay. Right. Come back to the trend projection. Projection is another word for the forecasting. The simplest form of time series is projecting the past trend by fitting a straight line to the data either visually or more precisely by regression analysis. I think better you read another couple of times the same sentence. Okay. Then the linear regression analysis establishes a relationship between dependent variable and one or more independent variable. You know this one, right? So, for example, this is dependent variable and this is x1 independent variable. This is called simple linear regression because one independent variable. Okay, if there are more than one independent variable, so this is called multiple regression. Now we have x1 and x2 as independent variables. If the data is time series, the independent variable is the time period. No? For example, if the data set is time series, basically simple t to represent time should come here as independent variable. So time is the independent variable. Okay. The dependent variable is whatever we wish to forecast. Suppose that this is sales over time. So that is the time series regression that we are using. Linear trend forecasting. So this is the regression analysis. We put hat here over these parameters to say this is estimated number. Now see, if beta or the B greater than 0, here we are getting some positive number. What does it mean? Very simple. Sales are increasing over time. With the increases of this time, this sales is increasing. Very simple. Okay. And the next, if B is negative, you get negative number here. What does it mean? Sales are decreasing over time. If B equals 0, what does it mean? Sales are constant over time, because over time sales is not changing. So this is how you can interpret the parameter, and before that you need to test this one for statistical validity. Either t-test or p-value test you can use for that. Statistical significance of a trend is determined by testing B hat or by examining the p-value for B hat. I think under QT also you studied this one. I also remind this one briefly. So you need to test. If the parameter statistically significant, then you can use it for other forecasting purposes. Now, as I explained you earlier, this is time series data set plotted. Now, draw us, fair line for this one. Right? Very much fair line. So if you draw a fair line, it will be like this. This is the secular trend. Right? Even though this line is look fair, some numbers below to the line, some numbers are above to the line. All the numbers not exactly on the line. Right? Then by extending this line like this, you can take for 2006 trend forecasted value and 2007, 8, 10 forecasted value by extending the same trend line. But we cannot take, for example, for 2007 somewhere here. So this will be the forecasted value. But remember that this is only the trend forecast. This is only the trend forecast. But the actual number may be sometime here or here. That's why we cannot take only trend forecasted value for policy making, because we cannot, the trend forecast not capturing cyclical and seasonal variation. So that's why there's a danger of taking trend forecasted value as our forecasted value. This measure only the trend, right? So if you take this line, there you see ups and downs, like this. Right? But even though actual number here, trend is giving us this number. So you are producing more, but actual sales is very less. So we need to capture those things as well to make most accurate forecasting valid. So this is 2007 one, 2012, like this. These are only the trend forecasted value. Okay, here the another data set is given, forecasting the sales from time period 1 to 15 are there. Time period 1 is 2007 January and 12 is 2007 December, and number 13 here is next year January, 14 next year February, and so on. If I put 20 here, you should be able to tell the time period. What is the time period for 20?
August
August, in which year?
2008.
2008. Likewise, you should be able to identify the real time period by this number. So, this is the plotted data and the trend forecasted, trend line, and extend this line like this. So, trend line, you estimated this trend line. You can do this one by, using regression techniques, right? The equation for the line is taking like this. You can use the same data set for SPSS, or even your scientific calculator will do that. You take this equation. Q hat is equal 46.57 plus 4.53 T. Here the T is independent variable, QT is the dependent variable. So, adjusting the number, suppose that you want to get year 2008 April trend forecasted value. How you can use this equation? Year 2000 April. What is the number? If you want to get the trend value for April,
16.
yeah, 16. So therefore, you need to plug 16 here. Okay, then this will be the trend forecasted value for time period 16. If you want to get 2008 May, what is the number? 70. Okay, then 17 you need to plug here. Then you will get this number somewhere here. This is how you can take the trend forecasted value for any period in the future, right? So if you put 20 here, what is the time period? So somewhere here, it is 2008 August, as you said. But we need to adjust this time, trend forecasting value for these ups and downs. Otherwise, this trend forecasting, we cannot accept as very much accurate forecasting value. So we'll do that a little later. So this is 17, this is 18, like this. Okay. Now another example. This is demand for electricity, time series data. Suppose that quantity measures in, I don't know, gigawatts or megawatts or whatever, measuring units, not that important here. Only we can deal with the numbers. Here, data set collected quarterly. We have 1997 first quarter, second, third, and fourth. After the fourth quarter in 1997, we're moving on to the next year, 1998, first quarter. Like this, we have taken the data for 4 years and we have data points 16 data points. Okay, starting from 1997, we are ending 2004 quarter. Right? Because why electricity example? Because not in the country like Sri Lanka, because even though we do have the same seasonal variation, I mean, winter, not winter actually, summer and autumn, spring. Sri Lanka, the difference between those period is not very much significant. Throughout the year, you're taking hot sun. Okay, sometime very rainy season is there, but not very much significant. But in some other countries in Europe, USA, Japan, in these countries and China also, the season is very much significant. They have winter. Even yesterday, I think there was an accident. The snow mountain fallen onto some village and some peoples, but not serious damage occurred. And India also has happened the same thing. Winter season, summer, autumn, and spring clearly noticeable. Right? During the winter, your electricity consumption is very much high. Why? So all the people using electricity for heating devices, right? And at the same time, during the summer, it's become too hot, right? The temperature in Colombo, maybe if passing 34, 35, it is very difficult for us to stay. But for example, in Japan, the summer season is going to 37, 38 or even 40s. So very tough. So you can't, it's very painful and very tough. It's difficult to survive. So during that, hard summer season, people using more and more electricity for cooling system, right? And other two seasons with average, autumn and the spring, these two significantly higher demand for the electricity. So that's why this data set used for this to identify those factors as well. In Sri Lanka, throughout the year, you can't see much variation in the electricity demand. Okay, because throughout the year, using almost same quantity. Whereas Wandru panel balance karagana bari I think, as they said, but on average it is constant. Okay, now I want you to get this pen, you write down this data set like this, right? Time, quantity, right? Time, actually you can put here 1997 1, and also you can put here under the simple T 1, and 2 is 1997 second quarter, right? And 3 1997 third quarter. Like this, you can write vertically these data set, and there should be some space here in front. we are going to do one exercise, and the quantity here 11, 15, 12, like this. You better write down now. And I want you to get this equation. Qt is equal A plus BT. Get these two values. I think you can use your computer or the calculator to get this number. Can you do that? One or two, please do that, and then tell me the equation. Because I have already done this one, right? Rather than straight away going and see that estimated equation, better if you can do and take the equation. In the next slide, answer for this question is there. Value of A is given, value of B is given. But still I want, few of you to do this. If everybody can do it, it's much better, right? If anybody is very much familiar with these numbers and SPSS or the Excel, or else your scientific calculator, do it quickly. So you can use maybe 3-4 minutes on that. Callum has taken A7D4. Any other answers? Without wasting time, shall we go to the next slide? Because you can see my answer. So better in some other time you can practice. This is the equation. QTO, this is equal 11.90 plus 0.394 T. This is how it should come. Okay. Now we have the data period up to 16. 16 is 2000. Year 2000 quarter 4. Suppose that we want to get the 10 equation for 2001 first quarter. Then what should the number that we need to plug here? Because number 16 represents this one, 2000 fourth quarter. We want to get 2001 first quarter. So what is the number should be here?
17.
17. So here 17 plug and taken this number. So it's representing first quarter 2011. If you plug 18 here, it is the second quarter of the same year. 19, third quarter of the same year. 20, fourth quarter of the same year. This is how you can take 10 forecasted value. I think it's clear for everyone.
Yes, sir.
Okay. Right. Now, what you want to do, we need to adjust this one at least for seasonal variation. There are two methods for this one. One is ratio to trend method. The other one is seasonal dump. Okay. So let's take little break and take your breakfast or else refresh with a cup of tea and then come back after maybe 20 minutes time. So I'll discuss these things after the break. Thank you.